So the assignment which is related to topic light. The first one, light is traveling into a semicircular glass block as shown in the diagram. The ray of a light reaches a straight edge and angle of incidence I and the critical angle is C. Which of the following statement is true at the straight edge? When angle is bigger, then the angle of incidence is more than the critical angle, then what will happen? There will be a total internal reflection. So in that case, all of the light will be reflected. If this angle is more than critical, all the light will reflect back. So statement 1 is not correct. It said no reflection, but there should be a reflection. If angle is bigger than critical, no light is transmitted. That's right. Like no light is able to pass out, all of the light reflected back in the same medium. That's why B is the right answer. In question, an electronics student is using an LED to make a traffic light model. He uses red, orange, and green LEDs. The table gives information about these LEDs. They are identified as 1, 2, and 3. Complete the table by filling the color of each LED. How you identify? The frequencies are given. So we have violet, indigo, blue, green, yellow, orange, and red with your red is having the longest wavelength and violet is having the shortest wavelength. So the three colors which we have red, we have orange, and we have green. So the one which is having the longest wavelength should be red. So this should be red. Then less than red, it should be orange. And then this should be green. Calculate the energy of the lowest energy photon emitted. So lowest energy photon means one which is because we have the formula E is equals to HF or E is equals to HC over lambda. So lowest energy means lowest frequency or lowest energy means longest wavelength. So the one which is having the smallest frequency or the longest wavelength, that will emit out the lowest energy photon. So we have to use, in this case, red. So E is equals to HF. H is a Planck's constant. The value will be given 6.63 into 10 to the power minus 34. And the frequency is 4.41. Always read the columns properly. Like it's written 10 power 14. So it is 4.41, 10 power 14. If you just substitute 4.41, you will get a wrong answer. So check the columns, like sometimes it's 10 power 3, 10 power 6, 9. So use the full value. When you're for calculation, use a value, full value. For substitution in the table, you can just make the exponent as a constant factor and write the smallest numbers. So this will be 2.92 into 10 to the power minus 19 joules. In question 3, a 60-watt filament bulb is used as a ceiling light. The bulb is 2.5 meter above the floor and is a 5% efficient for converting electrical energy. Calculate the visible light intensity, the radiation flux, and assume that the R from the source is spread over the total area 4 pi r square. So example, the lamp is there on the ceiling. And this floor is 2.5 meter. So we have the formula. The radiation flux it means how much power is there on a unit area, or flux is, it's like watt per meter square, or intensity is there. So radiation flux or intensity is equals to power divided by area. And what area we take? We take always 4 pi r square, where r is a radius, because like there will be so many points which are 2.5 meter from this bulb, so it will make a sphere. An area of sphere is 4 pi r square. So we can say the intensity is equals to power divided by 4 pi r square, where r is the distance or the radius from the source to the point where we are observing. What about the power? It's a 60-watt lamp, but it's only 5% efficient. Like 5% is converted into light, rest all of them is wasted. So what is a 5% of 60? So 60 multiplied by 5 divided by 100. So 30 divided by 10, which is 3. So only 3 watt is light energy, divided by 4, pi is 3.14, and the radius, the distance we take 2.5, so 2.5 square. That will give us the intensity, which is 0.038 watt per meter square. The next is increasingly a different type of a light bulb is being used, and it is coiled fluorescent. A 10-watt bulb with this type replaces the 60-watt and give the same visible light. Approximately 25% of a national power production is used for the lightning. Discuss why some countries have announced that the filament bulb will be banned for the next few years. As you don't find a filament bulb as common, so when you compare the points, you will compare. First thing, you can clearly see that the fluorescent lamps are more efficient as compared to that of a filament lamp. So less energy will be wasted, more energy will be useful. You just have to compare the values here, because like at same 10 watt, taking 10 watt and giving like taking 10 watt. It's taking 10 watt and giving out 3 watts. But for a filament, you can say it is taking 60 watt and giving out 3 watts. So if you compare the efficiency, like this is about 30% efficient, about 30%, and this was only 5% efficient. So, and if 30% efficient, so how much energy is wasted? So it is wasting like about 70% of the energy is wasted, lost. Here, what happened? 95% of energy is wasted. In question 4, a solar cell generates an EMF when a certain wavelength of a light incident on it. A student connects a solar cell in the following circuits. The student keep the intensity and the wavelength of a light constant, and he adjusted the variable resistor. Different current and different potentials are there. So what is the stopping potential? The stopping potential when there is no current, that voltage is called stopping. On the grid opposite, plot these results and draw a line of a best fit. The first 4 points have been plotted. So you have to actually plot a graph. The first four points have been plotted here. and draw a line of a best fit. Then calculate the power output of a solar cell when the current in the cell is 0.4. We need the power output when the current is 0.4. What is the potential across it? The potential across is 0.43. And we have the formula that P equals VI. In a curved graph, how to draw a line of best fit? You just draw a freehand graph, like join points to points. That is called a line of best fit in a curve. So here P is equals to VI. We will use the current is 0.4 and the voltage is 0.43. We multiply, we get 0.172 watts. If it's a best fit straight line, the number of the points above and below should be same. But if it's a curve, then draw a freehand graph. Like for in this case, what will the shape of the graph? It will be like this. So the graph will be somewhat like this. No, if the there's a difference. The line of a best fit can be a straight line or it can be a curve as well. Because for example, if I say the points are scattered in this manner, what is the line of best fit in this case? So line of a best fit in this case is a straight line. But what if the points are like this? Then what will the line of a best fit? So the line of a best fit will try to join the maximum point of freehand graph. So both are the line of best fits. A straight line is also, it depends on how the points are scattered. So line of best fit does not mean it's always a straight line. A line of a best fit can be a curve. You have to check the trend in the graph. Explain why the EMF of this cell is 0.52. So in this case, when you plot the graph, like example, 0.55 and 0.35. So 0.55 and 0.35. And this is 0 and 0.52. 0 and 0.52 will be somewhat here. And other points are like this. So when we plot this, so the shape of a graph, it will be like this. So why we say that the EMF of this is equals to 0.52? Because when there is no current, as the current is zero, if the current is zero, there is no voltage drop internally. No voltage drop internally, we have the formula that EMF is equals to IR plus B. If the current is zero, there is no internal voltage. If there is no internal voltage, the external voltage and EMF will be equal. There is internal voltage or potential drop internally if the current is not zero. Like example, if there is some current is from the battery or a cell, some of the voltage will loss internally and remaining will be the external voltage. But in this case, why we can say that the EMF of this cell is 0.52? Because when there's zero current, no current is there. So there is no voltage drop internally. So all the voltage is externally, and when there is external voltage, in that case, we have the formula EMF is equals to IR plus V. So this I is 0 here, as you can see. So if I is 0, so EMF is equals to V. So the output voltage is also equals to the EMF. Usually, when you have a graph for the voltage and current for a cell, the normal cell, IV graph. So normal cell IV graphs, it is a straight line like this. But this is not the normal cell, it's a solar cell. So for solar cell, what will happen? Still some surrounding light is there, which cause the current. That's why it does not follow the same trend as we usually have for normal cells, chemical cell. So that's why for a solar cell, the graph is somewhat like this. But if it was a normal cell, then the graph will be like this, the linear graph, straight line graph. Because for a solar cell, the voltage or the potential across the solar cell also depends on the light intensity. Calculate the internal resistance when the EMF across the cell is 0.4. The potential across the cell is 0.4. So we have the formula EMF is equals to V plus IR. EMF is 0.52. V is 0.4. I and R. What about I? When the voltage is 0.4, how much is the current? You can use the table. When the voltage is 0.4, the current is 0.5. So this will be 0.5. So this will be 0.52 minus 0.4 divided by 0.5. That will give us a value for R, which is a internal resistance, which is 0.24. Yes. So 0.24 ohm. The EMF of this particular cell is independent of the light intensity. The current increases as the light intensity increases. Add to a grid, show that the result might obtain if the intensity of incident light was increased. So the EMF of this cell is independent of the light intensity, and the current increases as the light intensity increases. Add to the grid, the lines show the result which we obtain. So if there is more light, like if this was our first graph, so if there is more light, there will be more current. So the second graph, but it will end at the same point. Because the EMF does not depend on the light intensity, the current depends on the light intensity. So any value you can take higher value, but it should end at the same point. As they mentioned, the EMF does not depends on the light intensity, but the current depends on the light intensity here. The diagram shows an apparatus for a light experiment on photoelectric effect. So in a photoelectric effect, when the light falls, it produces photoelectrons, and these electrons will move. When we apply the potential positive and negative, the electron will accelerate, and we have a current and voltage. So the light shown onto a cathode C, applied potential is there, a sensitive ammeter, a work function, Why the first ammeter reading is 0? So why this like when we use a photon with 1.8, why there is no photoelectric effect? So what might be a reason for that? The energy of the photon is less than the work function, because work function is 2.3, but like we are supplying 1.8 electron volt photon, but the energy, minimum energy to move out this electron, we need 2.3. So there will be no photoelectric effect, because energy must be either equal to or greater than the work function. Then the experiment is repeated using the same two photons. So if you use, intensity of a light is increased 4 times. So what is the effect of increasing the intensity? Increasing the intensity increase the number of the photons. So here this will be 0. Why this is 0? Because again the work function, like energy of a photon is less than the work function, so there will be no photoelectric effect. But this one, what we did, we increases the intensity. So if we increases the intensity, like intensity is 4 times. So this will also become, the more electrons will flow out, so the number of electron will become 4 times. So 5 exponent minus 12 multiplied by 4. So this will become 20 into 10 to the power minus 12. The next cathode metal is a lithium. Express the work function in joule. So how to convert the electron volt into joule? We have 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we have 2.3 electron volts, so it will be x joules, cross multiply. This will give us the work function in joules. That is 3.7 into 10 to the power minus 19. The UV light with a photon 4.8 is shown on lithium. Calculate the maximum speed. So first, the energy of the photon is equals to work function plus the kinetic energy. So first we work out the kinetic energy. Kinetic energy will be energy of photon minus the work function. Energy of a photon is 4.8 into 10 to the power minus 18, and the work function is 3.7 into 10 to the power minus 19. Look, when you calculate this, you cannot substitute the energy in electron volt. These equations are, the base unit is joule. So you have to convert into joule. So this will be the difference in energy, which will be 4.4 into 10 to the power minus 18 joules. And then use the formula, the kinetic energy is half mv square. So kinetic energy is 4.4 into 10 to the power minus 18. Half the mass of electron, it's a constant value 9.11 into 10 to the power minus 31, and then v square. Simplify the equation, 4.4 into 10 to the power minus 18 multiplied by 2 divided by 9.11 into 10 to the power minus 31, and that is v square. So you have to take a root to get the value for v, which is 3.1 into 10 to the power 6 meter per second. So this will give us the energy or the speed at which this electron will emit out from the metal surface. In question 6, the diagram shows a ray of a light through a rectangular glass. The frequency, remember the frequency never changes. So frequency won't change. What happened to the speed as it moved from air to glass? Speed will decrease and the wavelength will also decrease. So A will be the right answer. The refractive index, how to work out the refractive index? For the same glass, so you will use the formula N1 Sine theta 1 equals n2 sine theta 2. N1 is the refractive index of the first medium, which is air. The angle of incidence is 65, so sine 65 degrees. Refractive index of the second medium we don't know, and the angle of the refraction is 35. So we put 35. So it will be sine 65 divided by sine 35. That will be the refractive index of the glass, which is 1.6. And obvious A and B are totally wrong because it's less than 1. Air has a refractive index of 1. So as others are causing a greater change in speed, so they should have a higher refractive index. So these are some questions from assignment light.